Young people, welcome back. B&B in the house, y'all. Got a good one for you. We are dealing with equations again. So let's take a look at it. Chapter 2, Lesson 3, Solving Multi-Step Equations. Objective 1, solve equations involving more than one operation. Objective 2, solve equations involving consecutive integers. All right, guys, so first things first, we're not going to do objective 2 today. It's a real joy, but it's in the bottom half of this handout, and we're going to focus on the top half. We'll definitely take care of that if you need to, but consecutive integers is one of those really fun ones to do. Just got to understand what they mean by consecutive. However, students will be able to solve multi-step equations. The concept is equations. The skill is solving. Let's get into it, guys. All right, so nice looking handout, guys. As I already mentioned, though, top portion 1 through 4, middle portion 5 through 22, and anything below that, guys, we're not going to get to. We're not even going to probably do all of the middle section because it's repeated practice. Repetition. So once we hopefully get the skill down here, you guys can continue the rest of this handout on your own. But here we go. Solve each equation, check your solution. That's going to be fun because we are going to do that today. Solve each problem by working backward. So by working backward, I guess, not forward. I love to tell my kids, work the way it feels good. If working backwards works for you, then work backwards, work sideways, work upside down. Work any way is going to be successful for you. But what they're talking about here, guys, is recognizing what's happening. So a number, that will be our variable, right, is divided by 2, and then the quotient is added to 8. The result is 33, find the number. So those are my two operations, addition and division. So in other words, number 1, there's a number that's being divided by 2, okay? Then that quotient is added to 8. So I'm adding 8. The result is 33. So there's the equation, guys. Can't solve it without writing it. So wrote it out, and of course then I'll solve it by undoing. So the opposite of adding 8, right? Well, let's do number 2 and 3. We might write them all out and do them at the end. So 2 is subtracted from a number. The difference is divided by 3. Well, difference and subtracted, kind of the same thing, right? But the result is 30. So again, there's my equals 30. But what equals 30 again? Working backwards. Let's write it out. Something equals 30. What equals 30? A number that is subtracted from a number. And then, of course, that's divided by, that difference is divided by 3. And the result is 30. So again, working backwards, working forward, we're just writing out the equation. I can say the skill we're working on now is writing equations because it's on us to write the equation and solve it, right? So again, just working through them, guys. This one says the result is 49. So again, I can just say equals 49, but again, what's happening to the number that we do not know is multiplied by 2. So honestly, divide 49 by 2, right? The opposite. But backwards. Inverse operation, working backwards, figuring out. And also, guys, we can talk about steps, but let's get through this first portion of going from the words to the equation, going from the sentence to the equation. So the number is multiplied by 2. So we're going to write that as 2 times n. And the product, so that thing that's multiplied, so these multiplied in your product, is added to 9. So we're going to add 9. So again, we're also about, dividing by 2, we're also subtracting 9. 49 minus 9 is 40. And then 40 divided by 2 will be 20. So 20 times 2 is 40. 40 plus 9 is 49. I just did 3 verbally, but now we're doing 3 right in front of us. I'm sorry, number 1 right in front of us. So solving this 2-step. Now I call it a 2-step because there's 2 operations happening. I see division and I see addition. The opposite of adding 8, subtracting 8. By doing that, the 8 goes away on the left, and now it's just n divided by 2 is equal to 33 minus 8, which is 25. So So now undoing dividing by 2, I would multiply by 2. So there's multiplying the left side by 2 and the right side by 2. N is now equal to 15. We got it. So again, I'm going to be 100%. The skill was writing an equation, and then we went to solving the equation. And you guys talking about solving an equation with more than one operation? Well, in the words, divided and added. In the equation, we see the addition and the division. So we undo that. For 2, I got n minus 2, all divided by 3, is equal to 30. So again, what's happening here? I see subtraction and I see division. So in this situation, I do want to get rid of the division first. Undo that dividing by 3 so that we can have the variable in the numerator by itself. We'll still have a minus 2 with it, but I needed more room. So let's rewrite that, get some more room. So again, with n minus 2 being divided by 3, the variable n is being subtracted. They're subtracting 2 from it, and they're dividing by 3. So the opposite of dividing is multiplying, and that's why you see both sides being multiplied by 3. And again, we have the numerator that is left, because the 3 in the top and the 3 in the bottom will cancel each other. So now n minus 2 is equal to 90. And of course, the opposite of subtracting 2 would be to add 2. So again, as they said, to work backwards, guys, I'm just doing this the good old-fashioned way, solving a 2-step or a multi-step. Definitely give your instructor an opportunity to show you another way, another path. But guys, I am here to help you in understanding the algebra, and that's what we're doing. So for 3, let's understand how to solve it now, because we understood how to write it. Opposite of adding 9, the opposite of adding 9 would be to subtract 9. 2n is equal to 40 now. I subtracted 9 from both sides. The opposite of multiplying by 2 would be dividing by 2. 40 divided by 2 is 20, and there we go. Now I said to check your solution, and I just thought about pausing, but no. We've got a nice long one, and we're gonna be checking all day. So we're gonna have that opportunity to check solutions later on. What we're gonna do now, guys, is take care of this word problem. So there's a word problem at number 4, and we got word problems at the bottom, but again, let's get to what we get to. So 4, after Ricardo received his allowance for the week, he went to the mall with some friends. He spent half of his allowance on a new paperback book. Cool, he buys books with his own money. Then he bought himself a snack for $1.25. When he arrived home, he had $5 left. How much was his allowance? So this is that working backwards, right? If he only got $5 left, can you tell me how much he had in the beginning? How much was his allowance? Well, he spent half of it. So A is going to equal allowance, so A divided by 2. He spent half of it on a book. So, okay, all you know is he had some money, he spent half of it on a book. There you go. If he had $200, he has $100 now, right? Because he spent half on a book. But he didn't get $100 for the allowance, so not that much. I hope not. So I want to be in his house. I want $100 allowance. But, sorry, lost focus. He bought himself a snack for $1.25, so I got to subtract $1.25 because he bought a snack. But you know, at the end of the day, he went home and had $5. So again, if I said it's 20 divided by 2 would be 10 minus $1.25. No, that's not right. Now I'm just guessing, right? So instead of guessing, let's solve it. Undo the subtraction. So $5 plus $1.25, because I want to add $1.25 to both sides. And now I get A divided by 2 is equal to $6 and 25 cents. And now, of course, to undo the dividing by 2, we're going to multiply both sides by 2. Do it to the left and do it to the right. Keep that equation balanced, right? So the allowance that Ricardo got was $6.25 times 2, which will give me $12 and 50 cents. Am I gonna write that anywhere? Guess I'm gonna make it a little neater. I guess I wanted to make it a little less writing. So A is equal to 1250. Or in other words, if I wrote that out, Ricardo, and I knew I was going to do it because I want to give you my best. My best is me writing a sentence for the word problem. If they ask me in words, I'm going to answer in words. Ricardo's allowance was $12.50. Good, got it, gone. All right, guys, so again, took care of the whole top part. We're really going to focus in on the next. Ooh, that got going fast. But let's get it. So the next portion is the middle portion. What's pretty cool, guys, if you notice, we go 5, 8, 11, 14, 17, and 20. So by the time we get down to 20, we're getting to the more challenging. So we're going to focus in, get right into it. 5x plus 3 is equal to 23. What operations are happening here? Addition and multiplication. So undo the addition by subtracting 3 from both sides. 5x is now equal to 20. What number times 5 is 20? Well, let's show the inverse operation and then get a final answer of x is equal to 4. Now we're definitely going to slow down and check our solution. I like to call it a checkbox. Literally, it's a box I'm going to use to check. So 5 times x plus 3 should equal 23. All right, I put a little question mark, no question mark, just plug in. So 4, we got x equal to 4. 5 times 4 is 20, 20 plus 3, boom, bang, pow, 23 equals 23, it's checked. So literally like a check, it's like a checkbox because it's checked. Like that. All right, so again, guys, as we continue through this column, asking ourselves, what makes it a multi-step equation? It's more than one step. So with number 8, 6 plus 5c is equal to negative 29. So this is where I would ask my class, what operations do you see in this equation? And of course, I see addition, good. I see multiplication, good. So which are we gonna undo first? Undo the adding of 6 by subtracting 6 from both sides. The 5c comes down. That's going to be equal to negative, make sure you got this up right, 35. And that's where, of course, a mistake could come, but again, practice, 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 right? So what number times 5 is negative 35? Well, 5 times 7 is 35, so it must be 5 times negative 7. C is equal to negative 7. And here goes my check. 6 plus 5 times C is equal to negative 29. And again, I got negative 7. There's the question mark. Where's my box? It should be a check box. All right. Got lazy, I guess. Didn't want to draw a box. 6 plus a negative 35 equals negative 29. Yes, negative 29 equals negative 29. And we are checked. All right, guys, so again, from 5 to 6, now of course, as you get nervous here because you see what's coming, 11 has a fraction. I love it, guys, between 11 and 14, 17, and 20, really taking some time to make sure that you understand the simplicity of what's going on. A number is being divided by 3. N divided by 3 minus 8 equals negative 2. Again, what two operations are happening? Division and subtraction. What do we undo first? Addition or subtraction. So we're going to add 8 to both sides, recognizing that the fraction is just going to come right on down. But here's where I'm concerned. What do I do with the fraction? Man, it's easy. What's the opposite of dividing by 3? Multiplying by 3. So literally the answer is 6 times 3. But let's show a little bit more. Because on the left-hand side, I multiply by 3. On the right-hand side, I multiply by 3. So now the top 3 in the numerator and the bottom 3 in the denominator will cancel each other. That's why it's so simple, right? Or at least to me it is. And I hope you understand this concept. 6 times 3 is 18. And of course, guys, we still need to do our check. So if you have a variable in the numerator, very simple. Just multiply both sides by the denominator. Plug in 18 for n. 18 divided by 3 is 6. 6 minus 8 is negative 2. When I write negative 2 is negative 2. Oh, I'm going to show some integers. What? same change. Always add the opposite. Negative 2 equals negative 2. Got it. So again, guys, showing what happens when you have your variable being divided by anything, right? Opposite dividing is multiplying. So here with 14 though, I believe there's your curveball. Same as 11, except now it's a negative, but I need a D, not 9. Negative, yeah, I want to make this look really good. Boom. Because you can't tell me if the negative is in the numerator or the denominator. You can't. It's just right there at the division bar line. Mr. Barha knows what that line is called. One day he'll come in and tell you. But the opposite of adding 12 is subtracting 12. We get that. So I still have my fraction, negative D6, negative D divided by 6. Oh, you like how I said that though? Negative D divided by 6. No. Why can't I say D divided by negative 6? I can give that negative to whoever I want, but I know since it is a negative, I need a negative to get rid of it. So negative times a negative is a positive. So right now I'm going to multiply the left side by a negative and the right side by a negative so that variable D will not have a negative with it. And there it is, guys. I can give the negative to the numerator or the denominator. I gave it to the denominator. Now I see, I can get rid of that negative 6 by just multiplying both sides by the negative 6. The negative 6 in the numerator cancels the negative 6 in the denominator. And of course, well, I guess I'm doing that side first. Negative 19 times negative 6 is a positive 114. And of course, on the left-hand side, the canceling, there it is, top times top and bottom times bottom, right? Negative 6D is now on the top. Negative 6 is in the bottom, and guess what happens with the negative 6 and negative 6? They cancel each other, leaving you with 1. So 1D is equal to 114, or just D equals 114. So definitely, man, take a picture, write it down. Make sure you catch that one, guys. You're always going to have a negative fraction with your numerator being a variable, and just knowing to give that negative to the denominator is going to save you a lot of stress or complications moving on. Plugging in, again, that negative is right in the middle, so 114 divided by 6, whatever comes out, it is negative. So 19 came out. 114 divided by 6 is 19, so negative 19 plus 12, yes, it does equal negative 7, yes. All right, so again, multi-step equations, because you're doing more than one operation. Let's get that out of here and take care of our next one, where I have to tell you about my man, J. Cole, who put it in his lyrics, flipping like a reciprocal. That's right. So, 17 is 3/4 cubed minus 7. Again, I can undo minus 7 all day long. Opposite of subtracting 7, adding 7. Show it, get it, got it. But how do I now take care of the 3/4 cube? Well, the 3/4 cube, the Q is not in the numerator, it's not in the denominator, it's hanging on the edge. So it's like 2 times Q or 5 times Q, but it's 3/4 times Q. So guys, we're going to use what's called the reciprocal. We're going to multiply both sides by the reciprocal of 3/4, which is 4/3. Just flip it. Excuse me. The reason why we're using that reciprocal, guys, is watch what's going to happen. Top times top, 12. Bottom times bottom, 12. 4 times 3 is 12. 3 times 4 is 12. What's 12 divided by 12? Did I say that too fast? You see it, though. 4 times 3 in the numerator, 3 times 4 in the denominator. That's going to cancel out that fraction. So now I don't have a fraction in front of the Q anymore. I've got a big old 1. So 12 divided by 12 will be 1. So 1Q, or just Q. Then, of course, on the right-hand side, we have the 15 times 4/3. And I like how I put a invisible 1. So you can see 15 over 1, and then the 4 over 3, and 15 times 4, and 1 times 3, and 60 divided by 3 is 20. And you got it. So now, of course, our check. And again, you can't be afraid of the fraction. So 3/4 times what we got. Well, Q is 20. So I'm going to write it as a fraction. Because when I multiply a fraction times something, it better be another fraction. If it's not, I know how to make it a fraction. So So 20 becomes 20 over 1. So top times top, 3 times 20, bottom times bottom, 4 times 1. 60/4, 60 divided by 4 minus 7. 60 divided by 4 is 15. 15 minus 7 is 8. So yes, 8 equals 8. And I'm feeling good. Feeling good. So 20 is the exact same thing, guys. Again, this is where I tell you should go ahead and get a quick pause on your own and see if you can get it before I do it. Did you pause? All right. 4/5 m plus 2 is equal to 6. So again, what makes this a multi-step? Well, I have to undo the addition, which you're seeing now. Now we have to undo that multiplying 4/5 times m, which we're going to do right about now. Again, using the reciprocal. 5/4 on one side, 5/4 on the other side. So this is where I would ask the kid, are you going to use the invisible one? They go, nah, Mr. Kraft, I don't need it. I go, well, use it anyways. And there it is. Top times top gave me 20. Bottom times bottom gave me 20. So 20 over 20 becomes 1. So 1m, that's why we use the reciprocal. That's why we use the reciprocal. Sometimes I talk fast. Doesn't get out. But check it, right? And again, guys, what I want to point out again is I use that invisible one to make sure that you guys were kind of clear on how can I put this? But don't go away just yet. You guys are clear on how to multiply the fraction times a whole number. So again, when I had equals 4, 4 times 5 in the numerator was 20, 1 times 4 in the denominator was 4, 20 divided by 4 was 5. And guys, I think we got it. Or at least I've got the first part of this handout done for you. I hope this video was helpful. We're at a 20-minute time here, and guys, want to make sure our videos are a length at which are perfect for you. Come back, check out the second part if you need it. Thanks for viewing, guys. Peace out.